Good morning, children. How are you all? Okay, I am also fine. Today we will continue the acids, bases, and salts. So here in the last class we have studied about the pH scale. So P stands for potent. It is a German word, and that meaning is power. Also, we studied about the pH, importance of pH in our daily life. Okay, so that is usually the pH scale starts from 0 to 14. The pH value less than 7 are acidic, and the pH value more than 7 are basic. More than 7 and less than 14. And the neutral substances, usually the pH value is 7. Okay, so here the importance of pH in our daily life we have studied in the last class. That is the body, the pH value of the normal persons or our body, that is nothing but 7.0 to 7.8, and the pH value of acid rain, so that is less than 5.6. So if the rain pH value is less than 5.6, usually it is called as acid rain. And the next, the pH value in the mouth, if it is decreases or it is less than 5.5, then our tooth gets decaying. Okay, so that's about that we have studied in the last class. And now we are going to study about the salts, some of the salts. Okay, so usually salts is the salts is nothing but when acids reacts with bases, there is a formation of salt and water. Then here what happens when the strong acid reacts with strong base. When strong acid reacts with strong base, there is a formation of salt plus water. Okay, so here strong acid when reacts with strong base. Already we have studied in the last class about which are called as a strong acid and which are called as a strong base. Okay, depending upon the pH value and percentage of hydrogen, they are classified as a strong acid and strong bases. Okay, so here the strong acid, here the pH value is near to 0, and strong base, the pH value is near to 14. Okay, so when the reaction between strong acid and a strong base, there is a formation of salt and water. So here this salt, the salt which is obtained from strong acid and strong base, usually it is a neutral. It is a neutral, which means the pH value approximately, or it is exactly 7. Okay, so this is about the reaction between a strong base and a strong acid. For example, to take a strong acids like NaOH, strong acid like HCl, hydrochloric acid, strong base NaOH, sodium hydroxide, get sodium chloride, NaCl plus H2O. Okay, here when the strong acid reacts with the strong base, it is the formation of a salt and water. This salt exactly, usually it is also called as a common salt, which we are using in our daily life. We are using common salt. So this is a salt obtained by strong acid and a strong base. That is the HCl plus NaOH gives NaCl and water. And this strong salt, or this salt which is having a pH value 7, and this salt usually we are using to in our daily life to manufacture different or to make different substances or different compounds we are using in our daily life. So that is nothing but here the strong acids and strong bases. Okay, so here HCl plus NaOH gives NaCl plus H2O. So here the HCl is a strong acid and NaOH is a strong base, then NaCl plus H2O. Okay, so next here from NaCl, okay, already you know that from NaCl means sodium chloride. When it is dissolves in water, by passing the electricity or by passing the electricity, then what happens? There is a release of sodium hydroxide and also that is a chlorine gas. It will release the chlorine gas and hydrogen gas. So that process is called chlor-alkali process. So see here, we'll study about the chlor-alkali process. Okay, see here, strong acid, strong base, neutral substance, that is a salt plus water. Suppose if there is a strong acid with a weak base, what will happen? Strong acid plus weak base. There is also formation of a salt and water. Salt plus water, but this salt usually it is strong acid, means it is a acidic or less pH value, less than the pH value less than 7. Okay, so see here, when the strong acid reacts with a weak base, when the strong acid reacts with weak base, it is the formation of a salt, and that shows the acidic properties. It means its pH value is less than 7. Okay, suppose weak acid plus strong base, then what is the reaction here? See here, there is also salt plus water, but this salt usually it's a basic in nature. Basic, that is a pH value more than 7. Okay, see here, when these three sentences just here, when strong acid reacts, these three reactions just here, when strong acid reacts with strong base, salt and water, the salt which is obtained, that is a neutral, means pH value 7, exactly 7. When the strong acid reacts with a weak base, then there is a salt and water. This salt is acidic, the pH value is less than 7. When the weak acid reacts with the strong base, and weak acid reacts with the strong base, usually there is a formation of salt and water. And here the salt usually it is a basic, and the pH value is more than 7. Okay, so these three reactions you should know that one. Okay, the next we have to study about the sodium chloride. Usually the common salt which is using in our daily life, and by the sodium chloride we are using so many, or we are manufacturing, or we are making so many different substances or different things which is useful to us. Okay, now just here. Okay, see here, sodium chloride. Sodium chloride, nothing but NaCl, common salt. Okay, the common salt which we are using as a raw material, means we are using in our daily life as a common salt, and it is used to manufacture so many raw materials. So many materials like sodium hydroxide and bleaching powder. Already you know that bleaching powder, calcium oxychloride is called bleaching powder. Then next washing soda and baking soda. So these are nothing but we are manufacturing by the sodium chloride as a common. Okay, so that's why it is called as a common salt. And now how we can manufacture the sodium hydroxide by sodium chloride. Okay, here sodium hydroxide and NaOH. Okay, how we can manufacture the sodium hydroxide by sodium chloride? That is a chlor-alkali process. Usually, this is important for examination purpose. Carries 2 marks question, and that is a explain or write the chlor-alkali process. Okay, what do you mean by chlor-alkali process? Okay, when sodium chloride, common salt, and sodium chloride dissolves in water by passing the electricity. usually there is a formation of sodium hydroxide plus H2O plus chlorine gas plus hydrogen gas. Okay, so here chlor-alkali, chlor means chlorine, alkali means NaOH, so alkaline in nature, so that is a alkaline. Chlorine means chlor. So why it is called as a chlor-alkali process? We have now the products which are obtained by the reaction of sodium chloride with water by passing the electricity. We get the sodium hydroxide, that is a alkaline in nature, and chlorine gas. That chlorine gas will be released and hydrogen gas will be released. So this process is called as a chlor-alkali process. So we are obtaining here alkaline, that is sodium hydroxide, and chlorine gas. Chlorine gas we are obtaining that one. Okay, I hope all of you are getting this one. Explain chlor-alkali process means you should write that when sodium chloride dissolves in water by passing the electricity, the product will be obtained, that is a sodium hydroxide, chlorine gas, and hydrogen gas. So here the obtained product are chlorine. That's why chlor, and sodium hydroxide is alkaline. So that's why chlor-alkali process it is. Okay, by the sodium chloride, these are the sodium hydroxide and chlorine, and again by using sodium hydroxide and chlorine we will get so many different compounds. We will study that one. The first one we will study that one, bleaching powder. Okay, how the bleaching powder will be manufactured. So what do you mean by, or what is the chemical formula of bleaching powder? Okay, so here first we will study about the bleaching powder. Bleaching powder, chemical formula CaOCl2. Okay, calcium oxychloride. Calcium oxychloride. Okay, just here bleaching powder, that is a CaOCl2, molecular formula CaOCl2, and that is a calcium oxychloride. Okay, and see here bleaching powder, usually it is used in the to bleach the wood pulp in paper industry. First we will learn about the uses and then how it will be manufactured. Usually bleaching powder is used to wash or to bleach the wood pulp in the paper industry, as well as in the textile industry it is used to bleach the cotton and linen materials, and bleaching powder is also used to disinfect the water in to make free from germs. So bleaching powder is also used in the purification of water or to make free from germs. Usually we are using the bleaching powder. Okay, how we can manufacture the bleaching powder? Usually calcium hydroxide, that is a dry slaked lime. When chlorine gas is passed with calcium hydroxide or dry slaked lime, there is a formation of calcium oxychloride, that is a CaOCl2 plus there is a release of water. Okay, water. Okay, so here calcium oxychloride and water. When chlorine gas is passed through dry slaked lime, there is a formation of calcium oxychloride. So this is a bleaching powder and water. So see here, so this is nothing but the bleaching powder. Okay, calcium oxychloride, it is a bleaching powder. Bleaching powder. Okay, how the bleaching powder is manufactured here? When the chlorine gas is passed through dry slaked lime, so it is a dry slaked lime, then there is a formation of bleaching powder and water. And usually where it is used, the uses of bleaching powder, where the bleaching powder is used, usually bleaching powder is used in textile industry. Textile industry to bleach cotton and linen. Okay, to bleach the cotton and linen material, also the calcium oxychloride or bleaching powder is also used in paper industry. Paper industry to bleach wood pulp. To bleach the wood pulp. Okay. In the paper industry also we are using the bleaching powder, and also this is used in disinfecting water from germs. Okay, in the purification process also, and in laundry also it is used in laundry. Laundry also used to bleach the clothes. That is a domestic purpose also we are using the calcium oxychloride. Okay, so it carries 3 marks question. Write the manufacturing of bleaching powder and write with equation. Then write its uses. Okay, so how the bleaching powder? What is the bleaching powder? Chemical formula, molecular formula, calcium oxychloride, CaOCl2. How it is manufactured? By passing the chlorine gas through dry slaked lime. We will get the what? Calcium oxychloride in water. This calcium oxychloride usually is used in textile industry to bleach the cotton, and one more other use paper industry to bleach wood pulp, and disinfecting the water in the to make free from germs, and laundry usually to bleach the clothes. It is also using, that is a calcium oxychloride. It is about the bleaching powder. Okay, the next after this baking soda. Okay, so baking soda, NaHCO3, sodium hydrogen carbonate or sodium bicarbonate, NaHCO3. Okay, so here baking soda, how we can obtain the baking soda? Okay, so here NaCl is nothing but the common salt with water, carbon dioxide and ammonia, NH3. There is a formation of NH4Cl, that is a ammonium chloride, NH4Cl, and plus NaHCO3. This is nothing but the, okay, so see here what are the reactants here? Sodium chloride, water, carbon dioxide and ammonia. Sodium chloride, water, carbon dioxide and ammonia. These are the reactants. And what are the products here? Ammonium chloride and NaHCO3. This NaHCO3 is nothing but the baking soda. It is called as a baking soda. Usually where it is used, baking soda is used in the baking powder in bakeries and to cook the food, and it is also used in the food, that is as a baking soda. And it is baking powder. To manufacture baking powder, we are using the baking soda. Okay, and baking soda, it is also used as an antacid. It is also used as an antacid for the treatment of the acidity. Okay, and baking soda usually it is used in the soft drinks, that is a cold drinks and all we are using, and in the fire extinguisher. Okay, in the fire extinguisher, that is a soda water to produce the carbon dioxide in the soda by the soda acid fire extinguisher. Okay, it is used in the soda fire extinguisher, that is a baking soda to produce the carbon dioxide. Okay, in fire extinguisher also we are using. Okay, so that is a baking soda. Baking soda, how it is manufactured? What are the reactants here? Sodium chloride, water, carbon dioxide, ammonia. Okay, by these all reactants there is a product ammonium chloride and sodium hydrogen carbonate. This is also called as a what? The baking soda. And it is used in baking soda, usually used in the manufacturing of baking powder, which is used in the bakery items and in food. And baking soda is used as an antacid, and baking soda, it is used as a soda fire extinguisher, soda water fire extinguisher. Okay, so this is about what? The baking soda. And next, by heating this baking soda, we will get the washing soda. Okay, so here washing soda. So next, washing soda, Na2CO3.10H2. Okay, so here washing soda, sodium carbonate. So that is here Na2CO3.10H2. How we can manufacture here? So by heating NaHCO3, already we know that NaHCO3 means what? Sodium hydrogen carbonate or sodium bicarbonate or baking soda. By heating, so we will get what? Na2CO3. So Na2CO3, and by the recrystallization method we will get the sodium Na2CO3.10H2O. Okay, so by here this Na2CO3 plus 10H2O we get Na2CO3.10H2O. So this is nothing but the washing soda. So usually washing soda is obtained from the baking soda or baking powder, baking soda. By heating the baking soda, we will get what? The washing soda. And these uses of washing soda. What are the uses of washing soda? Here, the washing soda usually used in paper, manufacturing of paper, soap, glass industries. Okay, so here washing soda is used in the manufacturing of paper, soap, glass industries. Okay, in glass industries. And washing soda is used to remove permanent hardness of water. To remove permanent hardness of water. Permanent hardness of water. Usually, the washing soda is used to remove the permanent hardness of water. And washing soda is used in the manufacturing of soap, paper, and glass. And washing soda is also used here for the domestic purpose, to wash the clothes. Usually for domestic purpose, to wash the clothes, we are using what? The washing soda. Okay, so here how it is manufactured. Washing soda is obtained by heating sodium hydrogen carbonate. We get washing soda, and the uses of washing soda are usually it is used in the manufacturing of soap, paper, glass industries, and to remove the permanent hardness of water, and it is also used as a domestic purpose. That is a washing soda. And last bit of the chapter, that is a POP, Plaster of Paris. Okay, here Plaster of Paris, CaSO4 half H2O hemihydrate, calcium sulfate hemihydrate. So that is called as a Plaster of Paris. Okay, usually the Plaster of Paris, you know that POP, where it is used? It is used by the doctors for the support of plastering to the broken bones. Okay, and also Plaster of Paris is used in the manufacturing of statues and in the constructions as a decorative purpose. Also we are using the POP, Plaster of Paris. Okay, how it will be obtained, how it will be manufactured, Paris of plaster. Okay, by heating the gypsum. Okay, gypsum, CaSO4 0.2H2O, that is the gypsum. By heating the gypsum at a 373 Kelvin, by heating calcium sulfate, that is a gypsum, and we will get what? By using 1.5 water, that is a CaSO4 0.half H2O. So this is what a POP, Plaster of Paris and this is what? Gypsum. So see here, by heating the gypsum at 373 Kelvin, will obtain plaster of Paris. Okay, plaster of Paris, and this plaster of Paris again, it's a reversible process. But again, when we keep the plaster of Paris in moisture, it absorbs the water from the atmosphere, and again it will become hard. That is a gypsum. So that's why usually plaster of Paris, it is stored in a moisture-proof container. So the question will be asked like this: why plaster of Paris is stored in moisture-proof container? Explain. Because usually this reaction is a reversible reaction. CaSO4 half H2O. Okay, when it is by adding water, means by taking the water, usually by taking water it will again turns into the gypsum. Okay, from gypsum by heating will get water POP. Again by adding water, the POP it becomes water, the gypsum. That is a CaSO4 half H2O plus 1.5 H2O by taking from the atmosphere, again it will become CaSO4 H2O. Okay, so this is a, to avoid this problem, usually plaster of Paris is stored in a moisture-proof container. Okay, moisture-proof container. So this is a what? The POP, and here it is a gypsum. Okay, usually how the gypsum is obtained? How the plaster of Paris is obtained? So by heating gypsum at 373 Kelvin, you get what? Calcium sulfate hemihydrate. So that is a POP. And where it is used? POP is used by the doctors. Usually orthopedicians, the orthopedic doctors used for the supporting of the broken bones. And POP is also used as a statues, as well as in the decoration, or in POP is also used in the construction of buildings and all. Okay, so when the POP it is exposed to air, it absorbs the water, and becomes hard material, that is a gypsum again. So to avoid this problem, usually plaster of Paris is stored in a moisture-proof container. Okay, I hope all of you are understood this one. Okay, so these are the 4 compounds which are using daily life. So that is which are those? The first one is usually common salt, that is a NaCl. It is obtained by a strong base and strong acid, and by the strong common salt, by dissolving in water, by passing the electricity, will get water. Chloralkali process, there will get sodium hydroxide and chlorine gas. And again the first one, bleaching powder. Bleaching powder is nothing but calcium oxychloride. By passing the chlorine gas to the dry slate lime, will get what? Calcium oxychloride. And baking soda. Baking soda is nothing but, so here by the adding of by the reactants, means the reaction between the reactants sodium chloride, water, carbon dioxide and ammonia, will get water? The sodium hydrogen carbonate and ammonium chloride. That is not, the sodium hydrogen carbonate is nothing but baking soda. And the next, by heating the baking soda, will get what? Washing soda. That is a Na2CO3 10H2O. And washing soda uses also we have studied. Usually the washing soda is used in the manufacturing of soap and glass and paper. Okay, the next, washing soda is also used to remove the permanent hardness of water. Okay, the next last one, that is a gypsum. Okay, so from the gypsum, by heating the gypsum, we will get water? Calcium hemihydrate, that is a calcium sulfate hemihydrate, that is a POP. That this POP is usually used by the doctors for the supporting of the plastering, by plastering to support the broken bones by the orthopedicians. Okay, and also the POP is used in the manufacturing of statues and all. Okay, the next here one question will be asked like this: when the plaster of Paris exposed, it absorbs the moisture, water from the moisture, and it will becomes hard and converts into gypsum. To avoid that problem, usually plaster of Paris is stored in a moisture proof container. Okay, I hope all of you are understood. Okay, from this POP, the chapter finished now. Okay, we'll start the next chapter by tomorrow. Okay, thank you, ma'am.